Did you know ultra-high intensity blasting, UHIB, could be a solution for power-constrained comminution circuits? A recent study conducted by Whittle Consulting shows that it has the potential to increase metal production capacity significantly. Capital and energy are the biggest cost types in base and precious metal mining. The process plant capital usually accounts for the largest chunk of the initial investment. More often than not, the comminution circuit, which is the largest and least efficient energy-consuming unit operation, becomes the metal production bottleneck. Increasing the intensity of blasting fragmentation, typically the most energy-efficient unit operation, may offer a solution. This example of mine-to-mill optimization revolves around the idea of increasing blasting intensity to debottleneck a power-constrained comminution circuit by shifting energy requirements from the least to the most efficient component. As blasting intensity increases, more energy is applied to in-situ rock, which increases fragmentation and softens the rock fragments by creating billions of microcracks from the blast shock. The rock softening effect of microcracks is the primary enabler of reduced energy consumption in the comminution circuit. In this Whittle Consulting case study, we extend this concept by incorporating the practice of UHIB, ultra-high intensity blasting. The purpose of this study was to employ Whittle Consulting's enterprise optimization techniques, which dynamically links mining and mineral processing in a single holistic model, to evaluate the effect of UHIB design on mine-to-mill debottlenecking and enterprise value. Ultra-high intensity blasting has been tested at an industrial scale in 3 mining trials at customer sites of Orica Mining Services. All 3 operations are large, open-pit copper porphyry deposits at Codelco's Andina mine in Chile, Teck's Andacolo mine in Chile, and Newmont's Penasquito mine in Mexico. The results we found have been quite intriguing. Using cost and power metrics as inputs to Whittle Consulting's Prober Enterprise Optimization software, we assess the life-of-mine impact of variable fragmentation from UHIB on mine asset NPV. No capital was invested to deconstrain the pre-existing bottleneck of comminution circuit power capacity. The increases in ore and metal passing through the existing power bottleneck exploited the differences in energy efficiency of the blasting and comminution processes. The study found that metal production capacity increases of up to 40% were feasible for an enterprise that was mill power constrained, along with an NPV increase of 26%. Over a blasting powder factor range of 1.2 to 4.7 kg per meter cube, the total unit metal production cost for the case study was constant at $12 plus or minus 0.2 cents per ton of ore. Additionally, life-of-mine NPV per ton of carbon dioxide equivalent emissions increased by 52%, driven by the difference in energy efficiency of blasting relative to comminution. In conclusion, applying increased energy to rock breakage and surface area creation through conventional and UHIB blasting designs can materially increase metal production, cash flow, and mine NPV, while concurrently reducing life-of-mine carbon emissions. To find out more, please read our technical paper available on whittleconsulting.com.au/UHIB.